Hello students, so we are doing exercise 21a, prove trigonometric identities, isn't it? So in our previous videos we have already completed till question number 30 and today we'll start from question number 31 onward. Okay, so let's begin. Exercise 21a, prove trigonometric identities, question number 31. So in the left hand side we have cot a minus cosec a whole square, and in the right hand side we have 1 minus cos a upon 1 plus cos a. So we are asked to prove this. Let's do. LHS equals to cot a minus cosec a whole square, isn't it? This is what we have in the left hand side. So let's change this cot a into cos a and sin a form. We know that cot theta means cos theta by sin theta, isn't it? So let's apply this formula here. Cot a means cos a by sin a, minus this cosec a means, since cosec theta equals to 1 upon sin theta, isn't it? We know this. So cosec a means 1 upon sin a whole square. We have whole square. So let's take the LCM of sin a, same number, sin a, isn't it? So in the numerator we have cos a minus 1 whole square, isn't it? So if the number is like this, 3 by 2 plus 5 by 2, isn't it? The LCM is the same, 2 and 2, we write 2, and in the numerator 3 plus 5, isn't it? 3 plus 5 is 8, 8 by 2 is 4. So same thing, this number is same in the denominator, so we don't multiply in the numerator. Cos a remains as cos a minus 1. Okay, now let's apply this square individually. Cos a minus 1 and sin a, both are within the bracket, and this square is applied to both the numbers, isn't it? So let's apply this square individually. This means cos a minus 1 whole square upon sin a whole square, isn't it? Sin a whole square means sin square a. This square was for both the number in the numerator and denominator. Now I am applying this square separately, okay, for the numerator and for the denominator. Sin a whole square means sin square a. So in the numerator we have cos a minus 1. Now let me show you an example. Suppose we have 2 minus 3 whole square, okay. Can I write this number like this, 3 minus 2? Here we have 3 is negative and 2 is positive. Minus 3 plus 2. And can I convert this into this form? Whole square, we have whole square here. Minus 3 is plus 3 now, and plus 2 is minus 2. Can I do this? Absolutely I can do this, because let's see the result. 2 minus 3 is minus 1. Sign of greater number comes, isn't it? Minus 3 plus 2 is minus 1 whole square. So minus 1 square means minus 1 into minus 1. Minus 1 into minus 1 is minus, into minus is plus. So 1 into 1 is 1. Here we have 3 minus 2, isn't it? 3 minus 2 means 1 square. 1 square means 1 into 1 into 1 is 1. So either you write 2 minus 3 or 3 minus 2. When there is a square, then the result will be same. That means here we have cos a minus 1. I can write this as 1 minus cos a, okay, because we have a square. If there is cube, we cannot do this, okay. If other than a square, we cannot do this. If there is no square also, then also we cannot do this. Cos a minus 1 cannot be written as 1 minus cos a unless there is a square. When there is a square, the sign changes to plus. If there is power 4, then we can do this. If the power is even number, then we can write the negative number as positive and positive number as negative. If the power is odd number, then we cannot do that, okay. So I hope you got this. Now in the denominator we have sin square a. Sin square a means 1 minus cos square a, isn't it? Sin square a plus cos square a equals to 1, isn't it? So sin square a equals to 1 minus cos square a. This plus cos square a goes to the right hand side. So sin square a can be written as 1 minus cos square a. Are you getting me? Why not? You are very, very intelligent, isn't it? So let me continue this here. 1 minus cos A whole square. I will write this as it is because I need 1 minus cos A. 1 minus cos A whole square. Now in the denominator we have 1 minus cos square A. This can be considered as 1 square minus cos square A, because 1 square is 1, 1 1 is 1, isn't it? So 1 can be considered as 1 square and cos is already squared. So 1 square minus cos square A can be written as A minus B into A plus B form. So A square minus B square. That means A minus B into A plus B. Are you getting me? Let me explain this. 1 minus cos square 1 minus cos square A is actually 1 square minus cos square A. So this A square minus B square, this means A minus B into A plus B, or you can write A plus B first and then A minus B later. Okay, now we have 1 minus cos A in the denominator and 1 minus cos A in the numerator, and the power of the numerator is 2. So let's cancel this 1 minus cos A and 1 minus cos A from the numerator. Okay, so still we have 1 minus cos A in the numerator, 1 minus cos A, and in the denominator we have 1 plus cos A. So this is what we have in the right hand side, hence proved. Isn't this easy? I hope you got this. Let's move on to the next question. Number 32, we have cosec A minus 1 upon cosec A plus 1 in the left hand side, and we have cosec A upon 1 plus sin A whole square in the right hand side, isn't it? So let's do this. Left hand side, LHS equals to cosec A minus 1 upon cosec A plus 1, isn't it? So this can be written as 1 upon sin A minus 1 whole upon 1 upon sin A minus plus 1. So cosec A means 1 upon sin A, isn't it? Cosec and sin are reciprocal of each other. So cosec A means 1 upon sin A minus 1. Cosec A again 1 upon sin A plus 1. So this is plus 1. So let's take the LCM. Sin A and 1, the LCM will be sin A, isn't it? So 1 into 1 is 1, minus sin A into 1 is sin A. And in the denominator we have, let's take LCM here also, sin A and 1, LCM sin A. And 1 into 1 is 1, so this plus comes here, sin A into 1, sin A. Are you getting me? This sin A and this sin A can be cancelled. So 1 minus sin A upon 1 plus sin A, isn't it? But this is not the answer. We are asked to prove this. So let's multiply this. 1 plus sin A upon 1 plus sin A. Okay. Why am I multiplying this? Because we need 1 plus sin A in the denominator. So I need 1 plus sin A. So let's do this here. In the numerator we have 1 minus sin A into 1 plus sin A. This means A minus B into A plus B, which means A square minus B square. 1 minus sin square A, isn't it? A minus B into A plus B means A square. A square means 1 square is 1, minus B square is sin square A. And in the denominator 1 plus sin A into 1 plus sin A, the same thing, A into A is A square. So 1 plus sin A into 1 plus sin A is 1 plus sin A whole square. Are you getting me? Yes. So this is 1 minus sin square A and 1 plus sin A. Okay. Cos square A. Is it 1 minus sin square means cos square A. This is cos square A. Are you getting me? 1 minus sin square A is cos square A. Since sin square A plus cos square A equals to 1. So let us bring this cos square a, let us keep this cos square a in the left hand side, and 1 is already in the right hand side. So let us take the sin square a to the right hand side, 1 minus sin square a. So this is cos square a means 1 minus sin square a. So 1 minus sin square a means cos square a, isn't it? We need cos a. So in the denominator we have 1 plus sin a whole square, 1 plus sin a whole square. While solving this type of problem, we must constantly look into the product which we need, okay? So this is cos square a upon 1 plus sin a whole square, isn't it? So this is a square upon b square, isn't it? So a square upon b square can be written as a upon b whole square. Are you getting me? A square upon b square can be written as a upon b whole square. This square now applies to both a and b. Similarly, here we have cos square a and 1 plus sin a whole square. So let's write cos a upon 1 plus sin a whole square. Okay. Now this is the answer, equals to RHS. Hence proved. Isn't this easy? I hope you got this. Now let's move on to the next question. Okay. Let us do question number 33. In the left hand side we have tan square a minus tan square b, and in the right hand side we have sin square a minus sin square b upon cos square a into cos square b, isn't it? So LHS equals to tan square a minus tan square b, isn't it? So this can be written as, you know that since tan theta equals to sin theta by cos theta, isn't it? Sin theta by cos theta. So tan square a means sin square a by cos square a, isn't it? So minus tan square b means sin square b by cos square b. Tan theta means sin theta by cos theta. So let's take the LCM of the denominator, cos square a into cos square b, isn't it? Cos square a into cos square b. So we have this. Now we need to make this, isn't it? So let's multiply this and this, because cos square a into cos square b gives this. So cos square b into sin square a, sin, this is sin, okay, sin square a into cos square b minus, okay, cos square a into sin square b, cos square a into sin square b. So we don't need this cos square b and cos square a in the numerator, isn't it? So let's make this cos square b to sin form, okay? Sin square a into cos square b means 1 minus sin square b. Are you getting me? Sin square theta plus cos square theta equals to 1. So cos square theta equals to 1 plus sin square theta goes to the right hand side and becomes minus sin square theta. So instead of cos square theta, I can write 1 minus sin square theta. So this sin square a is this sin square a, and this cos square b is 1 minus sin square b, okay? Cos square b, angle is b, so we must write the same angle. Cos square b means 1 minus sin square b. Now this minus sign comes here. So instead of this cos square a, I write 1 minus sin square a. Okay, angle is a here, okay? Cos square a means 1 minus sin square a into sin square b. This is what we have in the numerator, and in the denominator cos square a dot cos square b. Or let's multiply this, sin square a into 1, sin square a into 1 is sin square a, plus into minus, minus sin square a into sin square b, sin square a dot sin square b, isn't it? So minus into plus, minus sin square b into 1 sin square b, because this sin square b is also multiplied with this, isn't it? There is bracket sign, so we must multiply this. Minus into plus is minus, sin square b into 1 is sin square b, minus into minus is plus, okay, minus into minus is plus, sin square b into sin square a is sine square A, sine square B. So in the denominator we have cos square A dot cos square B. We should not change this denominator because in the denominator we have the same number. So this is minus sine square A dot sine square B. Here we have plus sine square A dot sine square B. Same number, opposite sign, isn't it? So let's cancel this out, this and this. So let me continue here. This gives us sine square A minus sine square B, isn't it? Sine square A minus sine square B. Sine square A minus sine square B whole upon, in the denominator we have cos square A into cos square B. Cos square A into cos square B. This is square, okay? Cos square A into cos square B. So this is what we have in the right hand side, hence proved. I hope you got this. Now let's move on to the next question, question number 34. Let's do question number 34 now. We have sin theta minus 2 sin cube theta upon 2 cos cube theta minus cos theta in the left hand side, and we are asked to prove this equals to tan theta, isn't it? So let's begin. In the left hand side we have sin theta minus 2 sin cube theta whole upon 2 cos cube theta minus cos theta. Now let us take sin theta common from here, okay? We have sin theta and here we have sin cube theta, isn't it? So sin theta can be taken common. Within the bracket remains 1. Sin theta into 1 is sin theta. This minus comes here. So we have 2 sin square theta left, isn't it? 2 sin square theta within the brackets. So this 2 is 2. And there was 3 sin theta in here. 1 sin theta is taken out and 2 sin theta remains within the bracket. Sin theta into sin square theta is sin cube theta, okay? So in the denominator let us take cos theta common. Cos theta is taken common. Within the bracket remains 2 cos square theta, isn't it? 2 cos square theta minus this cos theta is taken common, so 1 remains within the bracket. So this sin theta by cos theta, sin theta by cos theta is tan theta. Are you getting me? This sin theta upon cos theta is tan theta. Now this 1 minus 2 sin square theta can be written as 1 is sin square theta plus cos square theta, isn't it? Sin square theta plus cos square theta means 1. So this is minus 2 sin square theta, 2 sin square theta. In the denominator we have cos theta. Oh, cos theta is gone, isn't it? Sin theta by cos theta is tan theta, so we should not write cos theta. 2 cos square theta minus 1. That means 2 cos square theta minus 1 means sin square theta plus cos square theta, isn't it? So this is tan theta. Now here cos square theta, let me write first, okay? This cos square theta first. Cos square theta and plus sin square theta minus 2 sin square theta is minus sin square theta, isn't it? Here we have 2 sin square theta, that is negative, and here we have 1 sin square theta, that is positive. So 2 sin square theta minus 1 sin square theta is sin square theta. 2a minus a is 1a, isn't it? So 2 sin square theta minus 1 sin square theta is sin square theta. Sign of greater number comes, so this is greater, 2 is greater than this, so minus sign comes here. And in the denominator we have 2 cos square theta, cos square theta. So let's multiply this, minus into plus, minus sin square theta, sin square theta, minus into plus, minus cos square theta, isn't it? So let me continue here, okay? So this tan theta comes as it is, tan theta into cos square theta minus sin square theta, cos square theta minus sin square theta whole upon, in the denominator we have 2 cos square theta minus cos square theta. 2 cos square theta minus cos square theta is cos square theta, isn't it? So minus sin square theta remains. minus sine square theta. So this cos square theta minus 1 and cos square theta minus sine square theta. This is square, okay? I forgot to write square here. Cos square theta minus sine square theta. This is cos square theta minus sine square theta. And here 2 cos square theta minus cos square theta is cos square theta. And this minus sine square theta comes here. So cos square theta minus sine square theta by cos square theta minus sine square theta can be cancelled. So this gives us tan theta. So tan theta is what we have in the right hand side. Hence proved, isn't it? I hope you got this. Now let's move on to the next question, 35, okay? Let's do next question. Question number 35. We have sin A upon 1 plus cos A in the left hand side and we are asked to prove this equals to cosec A minus cot A, isn't it? So let's do this. LHS equals to sin A upon 1 plus cos A, isn't it? So let's multiply this number by 1 minus cos A and 1 minus cos A, okay? I am multiplying the numerator and the denominator by 1 minus cos A. This can be done because this 1 minus cos A and 1 minus cos A can be cancelled. So this gives us this into 1. 1 into this is the same thing, isn't it? So I can multiply and divide by the same number. So sin A into 1 minus cos A. Sin A into 1 minus cos A. Sin A into 1 minus cos A whole upon 1 plus cos A, 1 minus cos A is A plus B, A minus B. That is A square minus B square. Means 1 square is 1 minus B square is cos square A. Now let me multiply this, okay? Sin A into 1, sin A minus sin A into cos A, sin A cos A, isn't it? Sin A into 1, sin A into cos A, sin A cos A, this minus comes here. So 1 minus cos square A is actually sin square A. Because sin square A plus cos square A gives us 1. So 1 minus cos square A means sin square A. Now let's do the same thing as we have done this in our previous video. Suppose I have 2 upon 3 plus 4 upon 3. 2 upon 3 and 4 upon 3. The denominators are same number. I can take the LCM like this and write 2 plus 4, isn't it? So 2 plus 4 is because 3 ones are 3. This 3 ones are this 3. That 1 into 2 is 2. This 3 ones are this 3. That 1 into 4 is 4, isn't it? We have learned this in our junior classes. So 2 plus 4 upon 3 can be written as 2 by 3 plus 4 by 3, isn't it? The same thing I am doing here, okay? This whole number is divided by sin square A. That means sin A by sin square A minus sin A cos A, sin A cos A by sin square A. Sin square A is taken LCM here, isn't it? So I hope you got this. Now this sin A we have in the numerator and 2 sin A in the denominator, isn't it? Sin square A in the denominator. 1 sin A and 1 sin A gets cancelled. This is sin square A, so this square and then sin A cancelled. Here sin square A and here we have 1 sin A, so this sin A and this square gets cancelled. Here we have 1 upon sin A, 1 upon sin A. Are you getting me? Because here we had sin square A, so 1 sin A and the sin A from the numerator got cancelled. So 1 upon sin A minus, here we have sin A and this sin square A. So sin A and sin A cancelled. Again another sin A is in the denominator, isn't it? So cos A upon sin A. Cos A upon sin A. Let me continue here. Equals to 1 upon sin A means cosec A, isn't it? Cosec A. Because cosec and sine are reciprocal of each other. So 1 upon sin A means sin A goes to the numerator and becomes cosec A. So minus cos A by sin A is cot A. Cos A by sin A is cot A. So this is what we have in the right hand side RHS. Hence proved. So this is question number 35. I hope you got this.